interesting topic to be given, and I guess hearing Diana's discussion about being in policy, going to the dark side, being a scientist that has worked a lot with industry and quite enjoys working with industry, that probably puts me in an even darker place. But the point I'd like to make is that I think as Australians and coral reef scientists, I think we have a very clear understanding of that the oceans are quite beautiful. They're also a place of great responsibility. They're also a place of where we've squandered many of the riches of the oceans, and I think this is particularly true of coral reefs, and I think we've heard about that already this morning, and I think we'll continue to hear about that over the next couple of days. Although I think that's best illustrated in a recent result from a cruise by the Census of Marine Life, which I'm involved in 4,000 metres near Crete, where we actually found more rubbish than life in 4,000 metres, which was quite a concern. Actually found no life, but a lot of rubbish. So my message, I have two messages today. One is a little bit different to the one we just heard. I personally think that as science we run some risk in terms of the able to be able to resource and undertake the strategic science to underpin things like policy development, management, and impact assessment and so forth. And I also think that one of the solutions to be able to resource but more than resource, access capability is greater engagement with industry. I think this because I think what the benefits of doing this is for industry is that I think that it'll help ensure a licence to operate for industry, but in a culture of supreme respect, industry should become leading stewards of marine life, supporting management measures, supporting research and monitoring, but whilst operating what you might call perfectly where society permits operations. Now, I'd like to illustrate this talk not by the Great Barrier Reef. I thought I'd go somewhere else, and so I'd like to illustrate it with the energy industry of northwestern Australia and take a particular focus on the developments around Scott Reef and the northwest, which we'll get in. But I would argue that the perspective I'm presenting is just as applicable to other places, including the Great Barrier Reef, where you have fixed infrastructure. And I would also argue that in the future, I think some of the fixed infrastructure issues and the area of influence of those fixed infrastructure will become quite significant for the GBR when you think of things like coastal urbanisation, increasing transportation, if you look at the minerals industries, for example, operations through there, and a variety of other issues. But first, some scene settings. I think I always include this in my talks. I think we should remind everybody that Australia is a blue nation. Our ocean territories are much larger than our land territories. Great wealth creation opportunities, but also great responsibility. But I'd also make a comment as coral reef scientists that except for some of the people involved in the engineering and the technological end of the spectrum, we don't have a great experience of working with industry. We tend to focus on issues around knowledge and understanding, issues around identifying threats and consequences, issues around meeting management and regulator needs, and most of that support has come from government, as you saw the figures that Diana put up before. And we're going to hear a lot about some of that excellent research over the next couple of days. But from my perspective, if Australia and us as an essential element of the innovation portfolio, innovation group in Australia, that we're going to achieve the goals of understanding, protection, sustainable use, wealth creation and so forth, we really need to change the way we perceive industry in terms of working with them around this issue of licence to operate. But it's issues around strategic research, not issues around impact assessment. And as I said before, similarly, I think industry needs to recognise that a licence to operate from society is much more than an operating permit and requires taking on greater responsibility for stewardship and supporting research and improved understanding of our marine estate. And I think we're starting to see some of this change in the oil and gas industries of northwestern Australia. But first of all, a little bit more scene setting. So when this slide up here is simply a plot of light, it's basically light from the Earth, measured at the top of the atmosphere. And it's pretty obvious what it shows is, a lot of light out of the US, a lot of light out of Europe, and a lot of light out of Japan. If you then basically do the simple plot of converting that, saying, well, what if everybody, or what if the 6.4 billion people on the globe actually emitted the same amount of light as in the US, and that it basically shows you, and then if you take that a little bit further and look at the flux, really what it shows is the obvious, the emergence of China and India in terms of energy demand. In this case, light. The same thing would happen if you use the issues of mobility, energy for mobility. You'd get the same sort of plot. Then, if you superimpose on that Australia's gas resources, particularly liquid natural gas, what you see is that Australia has a tremendous amount of LNG, and a lot of it's concentrated up in the northwest. And if you go back, it doesn't mean, you can quickly see, you've got the resource there, you've got the market there, and that equates to significant offshore LNG development in northwestern Australia, with already about over $35 billion of marine-related projects in this sector already on the books. So there's also some greenhouse considerations in here, because in terms of an interim measure, there's an emerging view that LNG is probably a step in terms of some of the greenhouse considerations under Australia's energy policy. But as well as these massive gas reserves there, we also have some quite interesting coral reefs in this region. And here we have the Scott Reef. It's an area of significant values in terms of biodiversity, significant values in terms of coral reefs. And so what you have there is quite an interesting juxtaposition of high conservation value and possible location for large liquid natural gas facilities. And actually, if you go back, and we'll see later that, one of the major gas resources sits underneath Scott Reef. So what are the, just a little bit more contextual work. Scott Reef's up in the, as I said, the northwest. It's one of a series of reefs. You've got Ashmore, Scott, Rolly Shoals along that coast, and probably quite extensive fringing and other coral reef resources around the coastal areas, particularly around the Kimberleys, that we know very little about. They're also reasonably isolated in the sense there's 250 kilometres between those reefs, for example. And I'll use Scott Reef because my institution has been operating in this area since 1993 and has accumulated quite a bit of information about that region, including Scott Reef. For example, and I think, again, this is to illustrate where the funding comes from, we've spent about 30 million of, best calculated over that period, about 2.7 million from industry. So when you looked at this interesting question of, large LNG resources, I think it'd be pretty clear they're going to be developed, high conservation value. So what are the conservation and development decisions for those conservation and development decision? What's the information that's really required? And I've really just looked here in terms of the Commonwealth and the WA context here and grossly oversimplified these, but really I think it can be broken down into 4 questions, the status of the biodiversity, process understanding, natural dynamics and how the system will respond to disturbance, how important are these communities in a regional context, and really the outcome, what's the ideal situation is a thorough understanding of the reef complex's environmental setting and the drivers of pattern and change in an ecological communities, classic environmental risk type issues. There is, however, if you look at that, so that's really what's, if you go through those processes, that's the sort of information that's that's the sort of questions, the information is available to answer those sorts of questions. And it fits into a fairly clear environmental impact assessment process that industry needs to go through. That's, again, if you can grossly simplify it to, it's all about predict the extent and severity of impact and outline the proposed management strategies to contain impacts. Really, that's what it's all about. And in doing that, the regulator really sets some criteria, and again, in the context of northwestern Australia, a gross oversimplification, but I think you can break those criteria into these four sorts of questions. What will and won't be impacted, where are the sources of predictive uncertainty, what is the level of confidence in the predictions, and what's the implications for getting it wrong. Remembering this sort of fixed infrastructure type activity, once you've got it in place, it's virtually impossible that you'd ever do much about it or move it. So it's clear from that process and from those sorts of issues arising that there is a requirement for robust marine science, and it's a requirement that's basically required by both the regulators and industry, and you could also, if you want to step back, the managers and the policy people that are overseeing a lot of this. And so I guess the question arises, who's responsible for providing the resources to do it? Is it a government responsibility, is it an industry responsibility, or is it both? I suspect it's latter, because when you actually look at the benefits from it, the benefits clearly flow through. Again, I'd like to illustrate this with the Scott Reef example. Before that, I just want to take you through, because I'm not sure in this audience there's a lot of understanding of the processes around a development like an LNG plant off the coast of Australia. Really, these, and I think the messages here of this rather complex diagram is that the process goes through some fairly clear steps of resource identification. Usually that's the prospectivity issues, that's usually done by government. Resource allocation, usually a competitive process. A retention period, demonstration that you have the rights to retain it. Then there's this sudden development decision, which puts you into a development process, and then you'll move into operations. The other thing, just using the Scott Reef, this can take a very long time. So, for example, the joint venture group that has the rights to Scott Reef got those resource allocation rights in 1969. We're now in 2006, and that's that retention period. I think the other thing to take from this diagram is that once you make a development decision, you quickly get into this impact assessment, environmental management questions about controls identification, controls agree, and so forth. And this is very much about consultancies, from a science perspective, it's very much about providing very clear cause and effect type information. But what I want to focus on is this period down here, a very long period where there is work done and done by industry as part of their retention process, and I think that's an area that we can take some advantage of in the current climate to really get some focus on strategic research. I also think it reflects some changes in industry in terms of their views about community engagement, about funding of science, and about the recognition that in these assessment processes they're running into some major problems and major issues about getting permits because of the lack of clear or lack of solid underpinning science. So let's just have a quick look at Scott Reef. Have a look at what we know from, I'll pick on my own organisation from, work since 1993, what we know about Scott Reef, and how does it actually, how useful is it in terms of addressing those underpinning science questions, but also the criteria around environmental impact assessment and environmental management. So, first of all, I think, and I'll just quickly run through this set of slides, but happy to talk to anybody after it about and give them some details. I think the first thing, we know a lot about corals, we know a lot about fish, a bit about molluscs and a bit about habitats, so we can do those sorts of maps. We know a fair bit about the geology of the place, well known about the geology, mainly related to the whole issues of exploration for gas. Now, it's a very interesting continental shelf atoll on the edge of the shelf. We know it's isolated. We know there's very few anthropogenic pressures except for some traditional inverted commas fishing. We know it's a reasonably big reef, 650 square kilometres. It does get impacted in terms of traditional fishing from Indonesia and East Timor, which in more recent time is causing some issues around explorations, particularly around things like sharks. We know a lot about the bathymetry. We know in great detail about the bathymetry, both on and off the reef. We know a lot about the ocean climate, both in terms of its vertical structures and its horizontal structures, both in terms of descriptive sense and in a dynamic sense. We, for example, know a lot about internal waves there. This was developed both in relation to environmental issues, but also in terms of engineering risk. Know a fair bit about in terms of the productivity there, of how it's being driven by some of the nutrients from surrounding areas in terms of almost like upwelling processes going on in the region. We know a lot about disturbance events, particularly issues around cyclones. For example, here you have Cyclone Faye in March 2005, which actually hit Scott Reef, caused quite a significant bit of damage. Probably not an unusual event for the region if you look at actually the cyclone tracks for the past since 1980, and this is a high cyclone intense areas. Does cause a fair bit of damage, both in terms of the reef area, in terms of large varieties being washed up and so forth. And so we understand those processes, we understand the recovery from those processes, and the dynamics of the process. And finally, the issues around bleaching. When you look at, again, understand the whole issues around climate, particularly bleaching, both not only in terms of a reef context, but within reef context in terms of the site-specific information, and also the physical processes driving that. Again, both spatially, both in terms of the vertical profiles. Here, you can show that they bleached down to 30 metres for fairly clear reasons. The hot temperatures went down to 32 metres. We also know that in a horizontal sense in terms of currents and mixing. Talk about recovery, so you can talk about recovery dynamics from those sorts of issues, and know a fair bit about connectivity in terms of these are pretty much self-seeding reefs, and that in terms of ecological time there's very little recruitment from their surrounding areas. So what can we say in terms of what you might call the underpinning science? I really think in terms of answering what is becoming a fairly significant developmental issues up there. Biodiversity, know a lot about corals and fish, little else. How do they relate to the environment? Poorly understood. What are the natural dynamics? Again, corals, very well, little else. How important are the community, these areas in a regional context is pretty much unknown. And then if you go to the EI, the environmental impact assessment criteria, again, we're not in a very strong position in terms of being able to address those, and that does then cause problems for both industry and for the managers and for the regulators. And it also, I think, leads to uncertainty and risky decision making. So, summary and conclusions. I think that we need to increase our engagement with industry. I think the oil and gas industry is a good example of where that engagement, where there is opportunity for the engagement. I think that as a consequence, industry also, and is, recognising that a licence to operate from society is much more than an operating permit and requires taking on a greater responsibility for stewardship and research. I think there's clear benefits in that around knowledge. There's clear benefits about access to resource and capability for the sites, because again, I think the other thing as scientists, if we really want to access some of the marine technologies, these are the groups that have those technologies, and I think it provides improved certainty around industry and regulations. But I also would make the final point too, it provides us the opportunity, if we can engage early with these groups, to do some of the underpinning strategic science, so that we both can enhance our understanding of what are remote, difficult to get to large areas, and that would underpin these policy management and development questions. Thank you.